This is the second part of our video lesson for 5.4, where we're working on setting up and solving systems of equations given word problems. For question number 1, though, this one, if you haven't given a try to this yet, please pause the video and see if you can correctly graph this equation, and then hit play to check your work. So this was something people were having some difficulty with on the quiz. It was covered in the very first lesson of this unit. In order to graph a line, if you're going to graph it without using your calculator, you've got to get y alone. So in this case, I need to get rid of the 2 out in front of the y. So I'm going to divide everything by 2. That's going to give me y equals -3/2x minus 1. So my y-intercept is -1 here. And then I'm going to go down 3, forward 2 to get a decreasing line. Down 3, forward 2. Down 3, forward 2. And then I'll do the other points on the other side. And I'm going to connect it and label it. The next question that it asks is, it says this linear equation contains the point 2, k. State the value of k. So 2 is my x value. So I'm going to go over here to 2 on my x-axis, and I'm going to look for where my point is. Well, I can see that point is down 1, 2, 3, 4. So I think k is -4. Now, if we needed to support that algebraically, we could do the following. 2y equals -3x minus 2. I'm going to plug that value of x and y into the equation. So 2k equals -3 times 2 minus 2. So that would be -6 minus 2. And that would give me 2k equals -8. Divide both sides by 2, and I would get k equals -4, which matches with what I found in my graph. Question number 2. What I'd like you to do on number 2 is take a minute, pause the video, and see if you can set up a system of equations for this scenario. So the first thing I notice is that we have them ordering 15 tricycles and bicycles. So they tell me T is the number of tricycles and B is the number of bicycles. So if I add those up, T plus B, I should get 15. The second thing they tell me is that there's a total of 38 wheels. Well, a tricycle has 3 wheels. So if I have T tricycles, it's going to be 3T. And then a bicycle has 2 wheels, so it would be 2B. And the total of those, if I add those up, should be 38. Now it says in the set of axes below, graph the system. So I'm going to go ahead and use my calculator to help me graph this. And in order to do that, I'm going to look and see what is set up on my x-axis. On my x-axis is T for tricycles, and on my y-axis is B for bicycles. So I'm going to substitute, instead of T plus B, I'm going to use the equation x plus y equals 15 in my calculator, and 3x plus 2y equals 38. Now, in neither of these is y alone, which is okay. I just need to remember that I'm going to use a relation to graph this. So I'm going to hit delete relation, and I'm going to type in x plus y equals 15. Now, I can barely see that line, but that's okay. I'm going to hit menu, trace, graph trace. And the first point I see is 0, 15. So I'm going to plot that point to start with. When I look at my scale, my X's are counting by 1. So I'm going to press 1, enter, and I get 114, which makes sense because if there's one tricycle, there would be 14 bicycles. And I can see here that these points are going to go this way. Because every time I have one less bicycle, I need one more tricycle so that there's 15 total. And you can go ahead and connect those. One of the things I noticed with the equations you were graphing on your weekly reviews, you either need to graph, you've got to graph as many points as you can, and you've got to extend the graph to the very, very edge. So please make sure that you do that. If you extend it all the way to the edge of the graph, you don't need arrows. If you do not extend it to the edge of the graph, you must include arrows. In this case, I wouldn't include arrows because I can't have negative bikes or negative tricycles. So just consider that. This equation is T plus B equals 15. My second equation is right here. I'm going to go ahead and click tab. I'm going to type in my second equation, 3x plus 2y equals 38. And now I see that second line. I'll go menu, trace, graph trace. Now you'll notice I'm the relation 1 in blue is showing up in the bottom right of my calculator. If you hit your up or down arrow, it'll take you to your second equation. So I'm going to start with 0. And when I punch that in, I get 0, 19. So that's the first point I'm going to put on my graph. When I type in 1, I don't get a nice answer. 2, I do. So that's the next point I'm going to graph, 216. So my guess is I'm going to need to count by 2s. So then I have 413. $610. $8, 7. Oh, and interestingly enough, that appears to be where they're going to cross. 10, 4. 12, 1. And then I don't think I'm going to get to a nice point there. So I'll go ahead and connect these. And this equation is 3t plus 2b equals 38. So I've graphed my two equations. If you want to indicate an arrow, if your labels are too close, you can do that. It says here, based on your graph, could the recreation center have ordered 10 tricycles? So if I look at my graph, 10 tricycles would be here. And the problem is, could they have ordered 10 tricycles and have counted 15 total bicycles or tricycles and 38 total wheels? Well, it doesn't look like it. My graphs don't intersect here, so no. When it says explain your reasoning, if you ordered 10 tricycles, actually, we got to use the graph. So let's talk about this. Why can't that be the solution? The graphs do not intersect. at t equals 10. So that would mean one of your conditions was true, but the other one wasn't. They can't be true at the same time. Both conditions cannot be met with 10 tricycles. The only way both conditions can be met is if we order 8 tricycles and 7 bicycles. Okay. This was one of the questions that showed up on the lesson 5.4a. Now we're going to talk about how to solve these. So you had a lot of practice setting them up. Let's go ahead and take a look at how you would go one step further and finish solving this. So my system of equations is right here. What I notice is L is by itself. I know what L is equal to, so I'm going to go ahead and substitute that into my top equation. 204 equals 2 times 2W plus 6 plus 2W. I'm going to go ahead and distribute. Combine my like terms. 4 plus 2 is 6. Get rid of the 12. 192. And then divide both sides by 6. And I get the width is 32. Now, on word problems, go back and make sure that you reread what they want you to solve. In this case, it didn't say because I only took the first part of the problem. So I'm going to go ahead and find the length and the width. If the width is 32, the length would be 2 times 32 plus 6. So 64 plus 6, that would make the length 70. Okay. So again, it's really recognizing, are you going to use substitution or elimination to solve these? Here's the next one. This was the quarter question, quarters and dimes. So here's my system that we came up with. Because my D's, Q's, equals, and numbers are all lined up, I'm going to use elimination on this one. I can choose to eliminate the D or the Q. Doesn't matter. I think in this case, I'm going to go ahead and eliminate the D by multiplying the top by negative 0.10 on both sides. So you get negative 0.10 D minus 0.10 Q equals negative 3, because negative 0.1 times 30 would give you negative 3. I'll carry my second equation underneath, so 0.10 D plus 0.25 Q equals 4.80. And now I'll add these together. My D's are going to cancel. I'll get 0.15 Q equals 1.8 when I add those together. And my last step is to divide both sides by 0.15. So 1.8 divided by 0.15, and I'm hoping I'll get a whole number here. I get 12. That means that they had 12 quarters. To get the number of dimes, I know it's 30 that they need. So dimes, D plus 12 would be 30. So they must have had 18 dimes. Okay. So what I want you to do is go ahead and go through and complete this packet. The solutions are on our Google Classroom, so you can check your work.